And now, in this short lecture, we'll find out the area of the green semicircle. In the drawing, we have two semicircles. This is the first semicircle, and the second semicircle is this green semicircle. Know that line segment AC equals to 5 units in its length, line segment CV equals to 1 unit in its length, and our mission is to find out the area of this green semicircle. Okay, so first of all, we'll join points P and P together by a straight line. By joining points B and P together, we can do peripheral angle APB. So I'll copy this semicircle and the peripheral angle APB in the new page. This is the first semicircle from the original drawing that I copied, and we have here peripheral angle APB. This peripheral angle APB is subtended on AB, that is the diameter of this semicircle, and according to rule 7, peripheral angle APB equals to 90 degrees in its size. So I'll take quickly on rule 7. According to rule 7, if a peripheral angle is subtended on the diameter of the circle, it is equals to 90 degrees. Here we have this is a circle, and inside this circle we have peripheral angle ACB. This peripheral angle ACB is subtended on AB, that is the diameter of the circle, and therefore, according to this rule 7, peripheral angle ACB equals to 90 degrees in its size. So, according to rule 7, peripheral angle APB equals to 90 degrees in its size. So this is peripheral angle APB. And it is equal to 90 degrees in size according to rule 7. Likewise, I copy this green semicircle in a new page, but before that we join points P and C together by a straight line. By joining points P and C, we can do peripheral angle ACP. So I copied this peripheral angle ACP with the green semicircle, and we will implement rule 7 on this peripheral ACP. Actually, this is the main semicircle that I called from the original drawing, and this is angle ACP. Angle ACP is subtended on AP. This is the diameter of the semicircle, so I'll write it down. AP is the diameter of this semicircle, and here AB is the diameter of this semicircle. So here AB is the diameter of this semicircle that I copied from the original drawing, and because of the fact that peripheral angle APB is subtended on AB, that is the diameter of this semicircle, according to rule 7, peripheral angle APB, it is equal to 90 degrees in its size. Likewise, this is the great semicircle that I copied from the original drawing, and we have here AP is the diameter of this semicircle, and peripheral angle ACP, this is peripheral angle ACP that is subtended on AP, that is the diameter of this semicircle. Therefore, this peripheral angle ACP equals to 90 degrees in its size, according to rule 7. Peripheral angle ACP equals to 90 degrees in its size, according to rule 7. We define angle PAC, this angle PAC is alpha. Therefore, in the right angle ACP, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Likewise, we define angle PAB, this angle is alpha. So, in the right angle BPA, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. In the next step, we will prove that this right angle APB is similar to this right angle, triangle APC. Okay, so I'll copy the two right triangles in the new page and we'll prove that those two right triangles are similar to each other. So actually, those are the two right triangles that are going to the original drawing. Here, this angle equals to alpha, this angle equals to 90 degrees minus alpha. So we'll prove that those two right triangles are similar to each other. Which is to say, we'll prove that the right triangle APB, this is the right triangle APB, is similar to this right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. So actually, this is angle PAB. This right triangle PAB equals, and it is equal to this angle, angle PAC. In the right triangle APC, they are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle APB in the right triangle APB, and it is equal to this angle, that is actually angle ACP in the right triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus alpha, therefore they are equal to each other. So finally, this is angle ABP. And it is equal to this angle, that is actually angle APC in the right triangle, triangle APC. They are both equal to 90 degrees minus alpha, therefore they are equal to each other. So we actually proved that all the three angles in this right triangle APB are correspondingly equal to all the three angles in this right triangle APC. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. This is triangle APB. So triangle APB is similar. This is the sign of similar to this right triangle, triangle APC. According to angle similarity rule. repeat again, actually found out that the right angle APB is similar to the right angle APC according to angle similar to. So from the fact that those two right angles are similar to according to angle similarity rule, we derive that the following relationship exists between their sides. But before that, we know that AB in total equals to, here, now we are drawing, we have AB in total equals to 5 plus 1, that is 6. Again, AB in total equals to AC plus CB. AC is 5, CB is 1, so in total AB equals to 5 plus 1, that is 6. So AB equals to 6 units in its length, and here AC equals to 5 units in its length. This side AC is equals to 5 units in its length. From the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB in this right angle APB over side AP in this right angle APC equals to side is equals to side AP in the right angle APB over side AC in the right angle APC. Repeat again. From the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. That side AB in the right angle APB over side AP in the right angle APC equals to side AP in the right angle APB over side AC in the right angle APC. We have already found out that AB equals to 6, so we substitute AB by 6 over AP. AP is the missing side, so we leave it as it is, and it is equals to AP over AC, and AC is 5. So if we found out actually that 6 over AP equals to AP over 5. Here we cross multiply this equation and we get that 5 times 6 is 30. So 30 equals to AP times AP is AP squared. So 30 equals to AP squared. Here we take out of this equation and we get that AP equals to the square root of 30 units. So actually AP, this is side AP, that is equals to square root of 30 units in its length. But AP is the diameter of this green semicircle. If AP is the diameter, it means that AP over 2 is the radius of this green semicircle. So the radius of the green semicircle equals to AP over 2. The radius R of the green semicircle equals to AP over 2. AP is square root of 30, so it is square root of 30 over 2. So the radius of this green semicircle R equals to square root of 30 over 2. And the area of this green semicircle equals to the area of the circle over 2. So the area of the green semicircle, must be equal to the area of the circle, that is actually pi r squared over 2. So it is pi times r. R is equal to 30 over 2, and therefore r squared is equal to 30 over 2 squared divided by 2. So the area of the green shape equals to pi times equal to 30 over 2 squared. So it is pi, and square root of 30 squared is 30 over 2 squared is 4 divided by 2. So the area of the green shape equals to, we have here 30 over 2 is 15. So in total this expression equals to 15 pi over 4 square units. 15 over 4 is 3.75. So in total this expression equals to 3.75 pi square units. In terms of numbers, the area of this green shape, the green semicircle, equals to 11.78 square units. Repeat again, we actually found out that the area of this green semicircle equals to 11.78 square units. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found out the area of this green semicircle. So in the drawing, we have two semicircles. This is the upper semicircle with radius with diameter AB, and we have also the second semicircle is this green semicircle with radius with diameter PA. We also know that this is line segment AC, this equals to 5 units in its length, and this is line segment CB, this equals to 1 unit in its length. Again, our mission is to find out the area of this green semicircle. Okay, so I copied this, the upper semicircle in a new page. But first of all, we joined points P and B together by a straight line. And then I copied this upper semicircle that has the diameter AB. So actually, this is the upper semicircle that I copied from the original drawing. We join points P and B together by a straight line. By joining points P and B, we created a peripheral angle APB. Peripheral angle APB is subtended on AB, that is the diameter of this semicircle. And according to rule 7, any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, peripheral angle APB that is subtended on AB, that is the diameter of this semicircle, must be equal to 90 degrees in its size. Okay. Again, here AB is the diameter of this semicircle, and we have peripheral angle APB that is subtended on AB. Therefore, according to rule 7, peripheral angle APB must be equal to 90 degrees in its size. In the next step, we defined angle PAB. This angle is alpha. Therefore, the missing angle must be equal to 90 degrees minus alpha. 1, because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. In the next step, I copied this green semicircle in a new page, but before that we actually joined points P and C together by a straight line, and then I copied this green semicircle in a new page. Okay, this is the great semicircle that I copied from the original drawing. A joint point P and C together by a straight line. Here, AP or PA is the diameter of this semicircle, and by joining points P and C together by a straight line, you can get a peripheral angle PCA or SCP. Peripheral angle ACP is subtended on PA, that is the diameter of this semicircle, and therefore, according to rule 7, peripheral angle PCA equals to 90 degrees in size, because it's subtended on PA, that is the diameter of this semicircle. So, angle PCA, this angle, must be equal to 90 degrees in its size. In the next step, we define angle CAP as alpha. Actually, here you can see that angle alpha is a common angle that belongs to both triangles. Okay, therefore, this is angle alpha. So in this right triangle PCA, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. Okay, so in the next step, I copied both right triangles. This the right triangle APB, and this right triangle APC in the new page, and I proved that those two right triangles are similar to each other. Actually, those are the two right triangles that I copied from here, and we have in the next step we proved that those two right triangles are similar to each other. That is to say, we proved that this is the right triangle APB and it is similar to this right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, those two angles are both equal to alpha, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So actually proved that all the three angles in this right triangle APB are correspondingly equal to all the three angles in this right triangle APC, therefore those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationships exist between their sides. We derive that side AB in the right triangle APB over side AP in the right triangle APC equals to side AP in the right triangle APB over side AC in the right triangle APC. Again, we derive that AB over AP equals to AP over AC. AB equals to 6. Why? Because AB equals to AB in total equals to 5 plus 1, that is 6. So we substitute AB by 6 over AP. AP is the missing side, so we leave it as it is. And here we have AP over AC. AC, side AC equals to 5 units in its length, according to what is given us the question. So in total, we actually found out that 6 over AP equals to AP over 5. Here we cross multiply this equation and finally found out that 5 times 6 is 30, so 30 equals to AP squared. Here we took out of this equation and finally found out that AP, the missing side AP, equals to the square root of 30 units in its length. AP or PA is the diameter of this green semicircle. So the diameter PA of this green semicircle equals to square root of 30 units in its length. Therefore, the radius must be equal to half of it. That is to say, the radius of this green semicircle must be equal to AP over 2. Repeat again. The radius of the green semicircle must be equal to AP over 2 because the diameter is AB and the diameter over 2 is the radius. So the radius is AP over 2. AP is square root of 30. Therefore, square root of 30 over 2 is the radius of this green semicircle. And the area of this green semicircle must be equal to the area of the circle over 2. The area of the green semicircle equals to the area of the circle, that is pi r square over 2. And r equals to the square root of 30 over 2. So it is pi times r square. R is square root of 30 over 2, therefore r square is square root of 30 over 2 square divided by 2. So in total, the area of this green semicircle is equals to pi times square root of 30 over 2 square, that is r square over 2. So here we open the brackets. Square root of 30 over 2 is 30 and 2 over 2 is 4. So in total, this expression equals to 30 over 4 times 2. 30 over 2 is 15. So in total, this expression equals to 15 pi over 4. And 13 pi over 4. 13 over 4 is 3.75. So in total, this expression equals to 3.75 pi square units. And in terms of numbers, it is equals to 11.78 square units. I'll repeat again. We actually found out that the area of this green semicircle equals to either 3.75 pi square units. In terms of numbers, the area of this green semicircle equals to 11.78 square units. Okay, thank you very much.